Lecture 3 of the data mining class at Google. Today we're going to sort of get through as much of Chapter 2 as I can. We won't quite get through all of it, but we'll get through most of it. In case you're playing along, you know, this is the homework. It's due a week from today. By the end of today, you should know everything if you want to play along and do this homework. After the Tuesday due date, I'll mail around solutions if you want to check your answers if you're doing that. Okay, so we started on Chapter 2 last time. So we said sort of what is data, and we were imagining that the rows were different, what I call observations, what your book calls objects, and the columns were what your book calls attributes and what I call variables. And then we sort of talked about the different types of attributes. And so the main distinction was whether they were categorical or numeric. And some of you said, you know, what the book calls quantitative and qualitative doesn't seem that natural to you, and I agree. But the main distinction is categorical versus numeric. Your book calls categorical qualitative, and it calls numeric quantitative, and you can argue whether that's natural or not. So categorical, put over here, and then numeric, I'll put over here. And so that's sort of the first distinction, right? Every attribute's either categorical or numeric, or as your book calls it, qualitative or quantitative. And so that's the distinction discussed on page 26. After that, the categorical ones break down into nominal or ordinal, the distinction there being whether or not there's order. So it's either nominal or ordinal. And that depends whether or not the categories have order that you care about or you don't care about the order. And then the quantitative or numeric attributes break down into interval or ratio. So sort of think here, interval versus ratio. And the distinction there being simply that for ratios, we have a true zero and we can divide them, whereas interval really doesn't make sense to do the division. Examples, so ID numbers, eye color, zip codes, things like that are nominal. Now, a zip code you could argue, or ID you could argue, if you care about the order, it could be ordinal, but if you don't, it's nominal. Height, tall, medium, short, that would be ordinal. Things that are interval are temperatures in Celsius or Fahrenheit, right? You can't divide two Celsius temperatures and say it's twice as hot. Calendar dates, right? You wouldn't divide the 30th by the 15th to say this is twice as, you know, whatever, twice as far from the beginning of the month. That's an unnatural starting point. GRE score, wouldn't make sense to divide those. Whereas ratio, that's sort of everything else that's numeric. Things like temperature in kelvins, right? That's a measure of how much heat energy. So you could say this thing has twice as much heat energy. Length, something is twice as long. Time, something took twice as long. Counts, I have twice as many as you do, right? Those all make sense to divide. And then if it helps you, you can think about the mathematical operations that go along with these things. Things that are nominal are either equal or not equal. That's the only information you have. Ordinal, you know some sense of greater than or less than. Interval, addition is okay, subtraction is okay, ratio, division, and multiplication, and then everything includes everything else before it, right? So if that helps you think about these distinctions, then you can do it that way. And then the final thing we talked about is discrete versus continuous. And the truth of the matter is everything that's categorical is automatically discrete, whereas numeric can be either discrete or continuous. So I think I'll not write that down. I wrote that down last time. So that's what I said here, right? If it's categorical, it's always going to be discrete because they're distinct categories. Where if it's quantitative, it can either be discrete or continuous depending on the situation. So this was the example that I put up here, and so we can sort of run through these. This is the same as the homework problem in terms of the instructions, just the examples are different, and we can run through these. It shouldn't take that long. Basically, they want you to say, so this is that question 2 from the text. They want you to say whether or not it's binary, discrete, or continuous. So again, binary is just a special case of discrete, meaning it has 2 levels. And then once you do that, say whether it's qualitative or quantitative, and then qualitative, you should say nominal or ordinal. Quantitative, you should say interval or ratio. So this one's called in-class exercise number 3. So let's just run through these, and now stop me if you have any disagreement. So number of telephones in my house, that should be discrete. You can't own half of a phone. Let's see. Size of French fries, that's going to be categorical and thus discrete. Let's see. C, I own a cell phone or I do not. Now that's categorical, but it's not discrete. We would say that is binary, right? You can sort of save some memory by just allocating that to be binary. Okay, number of local phone calls you made in a month. So you can't make half a phone call, so that's also discrete. Let's see here. E, length of your longest phone call. Anything that you can measure you can think of being continuous, right? You can measure it as accurately as you want. I could say 10 minutes, I could say 10.1 minutes. Length of your foot, that's something I could measure. That would also be then continuous. Let's see, E, F, G. Price of your textbook, what did we say this one was? Discrete, right? Because you know, if Amazon is trying to store prices of books, they don't really need to allocate a float for that, right? I mean, it's only going to have 2 decimals, so we'll say that one's discrete. As long as it's money that you're spending, you can't have any more than 2 decimals. So let's see, E, F, G, H. Let's see, your zip code. You know, you can't live at a decimal zip code, right? Those are actually whole numbers, so discrete. HI, temperature in Fahrenheit. I can measure that as accurately as I want, depending on how good my thermometer is. HIJK. Same thing with Celsius. Same thing with Kelvin. Okay, so that takes care of that. Then the next thing is to say whether it's qualitative or quantitative. And then if it's qualitative, say nominal or ordinal. If it's quantitative, say interval or ratio. So number of telephones in your house, well, that's a number. So it's definitely quantitative. And it makes sense to divide, right? I can say I have twice as many phones as you, so that's ratio. Size of French fries, well, that's categorical. So your book calls that qualitative. And is that nominal or ordinal? Ordinal, right? Because you can think of this like if you permuted the large and the extra large, you've lost information, right? There's some information in the order. You know that extra large and large are closer than extra large and medium. There's some order to these things. Ownership of a cell phone, that's just simply qualitative, and that is going to be, let's see, we said qualitative, meaning it's categorical, and I'm just going to say that's nominal, because with 2 things, you can permute them, but you can't lose any information. If it's binary, there can't really be any order to the 2 things. So anything that's binary, I'm just going to call nominal. Let's see, number of local phone calls you made in a month, that's some number that's quantitative, and I can divide those things, so that would be ratio. Let's see, moving along, E, length of your longest phone call. That's got to be a number that's got to be quantitative. And again, I could divide the lengths and say I talk twice as long as you. That's ratio. F, length of your foot, also quantitative. And I can say my foot is twice as long as yours. We agree where the 0 is, right? 0 is where you have no foot, and then you start from there. We all agree where 0 is. Price of your textbook in G, that's also quantitative. And I can say my textbook costs twice as much as yours, so that's ratio. Let's see, zip code, discrete, qualitative, right? It's a categorical variable. And we're going to say probably nominal for that. Although, if for some reason you're getting order information from the zip code, like you know the small numbers are on the East Coast, you could say that this is ordinal. And if you look at the instructions in the book, they're sort of apologetic. They say some cases may have more than one interpretation. So it really depends, right? If you're using the order information in the zip code, it would be ordinal. If you're not, it would be nominal. The way to test yourself is say, if someone were to take your data and do a one-to-one mapping of all the zip codes to different numbers, would that lose information for you? If that represents a loss of information to you, then it's ordinal. If it doesn't, it's nominal. Okay. Then for the temperatures, right? So Fahrenheit and Celsius, well, all these are quantitative, right? In all cases, I'm computing some number. So these 3 are all quantitative. The only difference, though, is that with these 2 guys, I can't divide, right? Whereas this one I can. So these 2 guys are interval. Doesn't make sense to divide, whereas the last one is ratio. Okay. All right, so that takes care of that. That's the only thing I didn't finish up last time. Any questions on any of those? Okay, so we're done with that. Now, the question is, you know, when you're doing some sort of algorithm, does the software care about any of this? Well, it doesn't care about too much of it, but the one distinction it does care about is between categorical and numeric. Okay, the interval, the ratio, the nominal, the ordinal, not so important, but just at least getting the categorical separate from the numeric is pretty important. And in R, the 2 names given to these are qualitative or categorical variables are usually called factors, and the quantitative or numeric variables are usually called numeric. Okay, so to give you an example of that, you can take a look here. If you go back to that stats202 log.txt file we had last time, remember the first column was IP address, right? And so certainly we should agree that IP address ought to be coded as a categorical variable, or what R calls a factor. So let me just make a note of this. In R, things that are categorical that's synonymous with factor. And things that are numeric, right? Okay. So that first column in that data set should be should not be numeric, right? I don't want to add or subtract two IP addresses. They sort of look like numbers, but they have a lot of decimals in them. So you can see what R does with that, right? If you look at the first column here, so let me read in the data. Now let me sort of show you something here while I'm thinking of it. One way I often set my working directory is just by sort of grabbing the path from here. But this is sort of a funny Windows R incompatibility. If I do set working directory this will give me an error. What's wrong with that? Yeah. So that'll maybe save me some questions. If you wonder why it doesn't work, it's because that's not consistent. Okay, so that'll set my working directory to my desktop, and then I can just read in the data that we read in last time. I say header equals false because there's no header row. Okay, and so now I can look at the first column, and that is the IP address. I don't need that, so that says first column. And you see it spits out all 1921, 1922 rows at me. And then it says something curious at the bottom. It says 73 levels, and it starts to list them, right? IP address, dot, 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 another IP address. So what it's saying is that there's 73 unique levels. And so levels in R, when you have a categorical variable that's a factor, the levels are equal to the categories. And in this case, this one has 73 unique categories in this data set. So that's one way I know that it's treating this as a factor or as a categorical variable. Another way I could do, to determine that is I could say is.factor. The is.factor function will tell me if something is a factor. And in this case, it's true. And conversely, is.numeric will go to false. Okay, so it's treating that as a factor. Question?
It doesn't even try to order the numerical. It's a factor, right?
Yeah, so interestingly enough, if you sort, the sorting behavior is different. If you sort on something that's a factor, it will sort them in sort of a, well, it's hard to show with this example. It will sort them in sort of an alphabetical order, right? So see if you can see like an example of that. So in this case, it sort of follows the numeric order. But if you had like 223, it would sort it 223 for a factor. But for numeric, obviously, we go 2, 3, 20. Right. So it sort of will do a different bit of sorting there.
How does it figure out whether it's a factor?
Okay, so how does it know? So what we're doing is we're just sort of doing the default behavior, because I just read it in and took whatever it gave me. So what its logic it uses is, if everything's a number, it's numeric. Okay, if there sees any sort of funny characters, it will force it into a factor. Okay, and you can override these in the read.csv if you want. And I'll show you a little bit more about that here on the slide too. So the question was, how do you know, or how does it decide whether it's going to be a factor? The other thing I'll mention while I'm on this slide is that, of course, you can't sort of do, the usual numeric operations on these things. So it's a factor, so if I try to add 10 to it, it'll complain, and it'll give me all these NAs and a warning message that says plus is not meaningful for factors, okay? And later on, if I get a chance, I'll show you that Excel actually has a different behavior where it doesn't complain so much, which can kind of be bad and get you in trouble. Okay. So, it's sort of like, getting your types right when you're coding, right? You have to differentiate between the float and the integer. Here we're differentiating between the factor and the numeric. Now, if you look at the next if you look at column 8, that is a, numeric column. If you look at the data, let me see if I can show you column 8. So if I say data, column 8, that's a whole bunch of numbers. So you think, well, it should read that as numeric. However, it doesn't. Is.numeric column 8. Oops. Don't put what? Yeah, is.numeric data column 8. There we go, false. And is.factor would be true, of course. Okay, so the problem there is what? What's the problem with that thing? Why is the dashes, right? So, and you see when it says there's 27 levels and it lists the different numbers, but it also saw this dash, right? That's the problem with that one. So it sees the dash, and so right away it says this thing's going to be a factor. These aren't numbers, because there's something in there that's not a number. Now, if you look at the data set, you can see that the convention, whoever produces these logs, is to, whenever there's something missing, they code it with a dash, right? So if I say data text to columns, I'm just doing this so you can see it a little bit better. Space, right? Okay. See, so whenever something is missing, like here is a URL that's missing, and they just put a single dash there as a placeholder. So R is not used to that, right? R does not know that that's the character they're going to use for missing. So the way we sort of fix that, so let me get caught up to myself here. However, the 8th column looks like it should be numeric. Why is it not? How do we fix this? Well, it's not because it has that dash there, which means missing. So what we should have done when we read it in R is we should have told it that that dash means that something is missing. And the way I specify that in R here is, you see I say this last command, na.strings, which is an argument to the read.csv, and I can even actually give it a whole list of things here that whenever it encounters those, it will treat those as na. Once I do that, is.factor data column 8 now is false, and is.numeric column 8 is true. So now it's numeric, and now I can do something like data comma 8, and I can add 10 to it, right? And then the things that were the dash just show up as NA, okay? So R will treat it as numeric if everything's a number or one of the characters that you've told it is the missing value character. Otherwise, it will just treat it as a factor. And you can override these. If you look at the read.csv, there's ways in there to sort of force out the behavior you want if you sort of know what you're expecting. So you see as.is, string as.factor. So there's commands to do that, but I'm sort of just showing you what the default behavior is and to sort of show you how R differentiates between these. Okay, any questions on anything I said so far? Okay, so then the last thing I just wanted to mention is, suppose you're trying to create an attribute and you know that it's not numeric, right? So like here's some zip codes, and one of them starts 00123. I don't even know if that's a real zip code. So you say, how would you do this in R? If you just tried to say like zip codes to be the following, so zip codes store as the following vector, what I have 94550, 00123, 43614. If I do that, you can guess sort of what the behavior is. It's going to take that 00123 and cut off the 2 zeros because it thinks these are numbers, and it thinks I'm just being silly to put the 0 there, right? Okay, so how can you sort of override this behavior? Well, you want to force this thing to be a factor, and you sort of want to force these things to be strings and not numbers. So you could quote them, which would at least give you the keep the zeros there. Whoops. That's gonna, yeah, escape. Escape will get you out of that when you mess that up. Okay, there we go. So now you can see zip codes, and at least kept them around there. However, strictly this still really isn't a factor. So really what you want to do to force it to make sure it becomes a factor is as.factor. Now you can always sort of as.factor later on as long as you kept the 2 zeros along. So some of the algorithms will do when you pass things in, you can say as.factor at that time. But if I do that, then that will make my zip codes to be a factor. And you can see when it spits it out, it got rid of the quotes, right? Here it had the quotes. It got rid of the quotes, but it kept the 2 zeros, and it tells me there's 3 levels corresponding to my 3 zip codes. So the as.factor combined with the quotes will sort of give you the correct behavior that you want in that case. And you can sort of do help and read more about these. Question?
Do we still need the code if you?
Do you still need the quotes? That's a good question.
No, except that it'll remove those 2 zeros.
Well, then I guess I do.
When you concatenate them, it'll make them null. It starts as a number.
Yeah, I think I do. Yeah, so it's factor, but it's 1, 2, 3.
So what sort of data structure is the one which you did without as factor and put it as
So it's a list of, well, it's a vector of strings. And I'm loosely speaking, and I didn't want to say list because that's another special data structure in R. So it's a vector of strings, let's say that. So not necessarily a factor, which there's a little bit of ambiguity here. And sometimes, the types in R, it's a little bit ambiguous, and sometimes one will force out another. But to be sure, I think the as.factor along with the quotes will give you exactly the behavior you want. Okay, let's see where I am here. Okay, how would you create an attribute? Answer, we would use quotes and use the as.factor. Okay. Excel, not quite as picky, allows you to sort of mix types a little bit more. If you want to sort of force out behavior in Excel, the right thing to do is sort of click on the column, right-click and go to Format Cells, and then go to the Numbers tab. So let me sort of demonstrate that for you. So here's this data set in Excel. Suppose I didn't like the way it was treating this column. I'd sort of click on it once so that it gets highlighted. I would right click and I would say format cells, and you can change the font, change the border, change the alignment, but under the number tab here, it's sort of defaulted to general, but you can sort of ask it to do different things with it, and it has a lot of predefined formats, and you can also actually do some custom formats. So if you wanted to specify that this thing always had to be 5 digits or something like that, you could use that. And so I think then I ask you here sort of the same question. How would we create an attribute for these 3 zip codes in Excel? So you can see sort of what happens here in Excel. Let me open up a new file. New blank workbook. Okay, so I say like, what did I say, 94550, and then I try 00123. It cuts them off, of course, right? So the question is, how do I do this in Excel so that I can keep the 2 zeros? So I would just sort of right-click on the column and say Format Cells, go here to the Number tab, and I could force it to be text, for example. Text, okay. And now I say 94550, 00123, 43614. But now you see it's sort of mad at me, right? It puts that little green arrow and a yellow warning sign with an exclamation point on it. And if I ask it, it says here, the number in this cell is formatted as text or preceded by an apostrophe, right? Like, it looks like you're trying to write a letter, right? So you go here and you say, ignore this error, right? You know, and you can even ignore it, I think, for the whole column if you do it right. I forgot how to do that. Then the funny thing, though, right, is it knows these are text. But if you do something like this one equals this plus 10, it will still add 10. Well, let's see, hang on. Yeah, it did, right? It still adds 10 to it. So it doesn't really, like, even though I stored it as text, it still lets me add 10 to it, which is kind of funny, right? Whereas in R, you know, it told me, no, don't add 10 to your factor. Excel, you know, if it can add 10 to it, it will, right? So if you want to use, you know, I don't know, it's abuse of the language, but it's not as strongly typed as R is, right, if you sort of believe it that way. So Excel can kind of get you into trouble in that sense. Okay, so let's see here. Where are we at? How do I do this in Excel? I right-click on the column, then choose Format Cells under Number tab and select Text, and that will at least keep my zeros around, but it doesn't guarantee that it won't sort of let me do arithmetic operations on those zip codes later, even though I shouldn't be doing that. Okay, so I think that's all I wanted to say about types of data. I mean, we talked about all the different types, but the main distinction in the software is between the categorical and the numeric. And then beyond that, we have sort of different distinctions, which aren't so important to the software, but might be important when we do the analysis, such as whether or not you can divide 2 things or whether or not it makes sense to sort of subtract 2 things. Any questions about the different types of data? Question?
It's rather about R.
Mm-hmm.
What would you suggest as best materials for a programmer knowing that 20 different languages to learn this rather idiosyncratic one? I've fished around the data, found a 100 pages PDF by Berzani, but it's mostly teaching you elementary statistics and tossing in bits and pieces, maddening bits and pieces about the language. Right.
So the question is, for a person with a strong background in programming, you know, what can I read to help me understand R? Anyone know of any good books on that? You can write R-users at the obvious place, and they might be able to recommend some good books. When I learned it, it was like the first like programming language I learned, so I came at it from the complete opposite point of view, right? For a programmer to learn it, you know, I don't know of a good reference off the top of my head. It is built on C, if that gives you any better feeling at all. And no.
It's not object.
Yeah. So anyway, yeah, I don't know of a good reference for that or in general. There's some, I don't know, right? And you have to think it's like open source written by people that don't really know how to code that well in some cases. So you have to be a little bit careful. I mean, the people that built it did, right? But some of the functions and things like that do some sort of very strange behavior. Okay. Any other questions about the types of data in R or Excel? Okay, so the next thing I wanted to talk about is just sort of some basics with R and sort of how you manipulate data and things that you do there. So the first thing is, like, you've seen me use this C operator before, right? This basically creates a vector. If it helps you to remember, I used to think of C as being like column vector, even though it looks like a row vector. That's just sort of my mnemonic device. So I do AA store as 1, 10, 12. So that's a vector, and it takes the values 1, 10, 12. Okay, then what can I do with that? Well, I can do, you know, arithmetic operations on it. If you add a scalar to a vector, it just does the component-wise addition, and you get 11, 20, 22 as you would expect. Let's see, what else can I do here? The length function will tell you how long something is. So, that's similar, tells you length 3. And again, any of these functions, you can always ask for help, question mark length, and then it'll tell you sort of what it's doing. I think, let me see this. If you type this, what happens? Sometimes you can get to see, no, sometimes you can get to see sort of more about it by doing that, but in this case, I don't have it available to me. Let's see, what else do I have up here? So I can create another vector called BB. Now, one thing, this is sort of funny. Why do I call these AA and BB as opposed to AB? Because you don't have to go too far till you get to C, which is already reserved, and you get yourself in trouble because you overwrite C, right? C is that operator that makes these vectors. So now BB is a vector. I mean, you can get yourself in trouble the first time you're trying to do this. Okay, so now I'm going to create an object that's called a data frame, data.frame. And when you read data in, it usually comes read in as a data frame. This is sort of, the data frame is kind of like a matrix with row numbers and column headers. It's kind of the standard unit of data in R. And so I read this in a data.frame. Then I said attribute A equals AA. So whatever I type here is going to be the name of column A. And then whatever I type here is going to be the values that it takes, which is the values of my vector A. And then the other one I called attribute B and gave it the values BB. So now if you look at my data set, it sort of looks like a matrix, but see it has the row numbers and the column names, right? And so this is my data set. This is similar to something you would have read in. It has the column names attribute A, attribute B, and the values of column A are stored as attribute A and column B are stored as attribute B. And then what can you do with this type of structure? Well,
So the
yeah.
plus 10 didn't actually...
No. I would have to have done, I would have had to do, where did the plus 10 go? I would have had to do AA store as AA plus 10 if I wanted to overwrite it, right? Okay. And you could, also do CC if you wanted to create a new one, right? Okay. Yeah, the AA doesn't do that. Okay. Let's see. So there's my data set. You can index into this. I think I showed you this before. So for example, if you want the first column of it, you say my data set. Where did my data set go? There it is. My data set column 1. That will give you the first column, right? 1, 10, 12. Let's see what else you can ask for. The first row. Now, if you ask for the first row, it will give you the first row along with the column names, right? There's the first row, 1, 2. Some funny behavior. Well, so let me finish these first. 3. Huh? Yeah.
Does it copy the contents, or does that mean if you make further references to AA, it changes what's in the data set?
It's simply taking a static copy, right? So if I change AA, my data set will not change. Yes. Yep. Okay. So let's see. Go here.
The size of A and B is different, doesn't matter.
So that's okay. So what it will usually do in most things is it will take the longer of the two, and then the other column would have a missing value. Okay. Sometimes in other cases it will complain. This is a common error that the lengths don't agree, but sometimes it will. It also has some other funny behavior. If you do like AA fourth entry, right? Well, there is no fourth entry, but you could store something as a fourth entry, and it doesn't complain at all that that's out of bounds. It just makes it bigger. So that's sort of funny behavior too, right?
What if you do AA6?
Yeah, no problem, right? So you want to see what AA6 is?
Let's just skip 5.
And then AA6 store as this, and AA missing 5, right? So it just sort of like gets longer. So it has some funny behavior that, could be troublesome. You might expect an error, and it doesn't. Here I just index, this is the row 3, row 2, no problem. That's the value of 79. One thing that's funny, this used to get me, hang on, I'll get to it in a second. If I wanted the first 2 rows and all the columns, that would do the trick, right? Because this is the first 2 rows and all the columns. I want to get to the one that's sort of funnier here. Okay, this one always bothers me. If I ask for the first and third row and all the columns, right? So first and third row, I get it. Now the funny thing about this thing, though, is that the row numbers on this thing are still 1 and 3, right? So this thing sort of, its second row is numbered row 3. Why does that bother me? Because if I go back to this thing and I ask to see the third row of this thing, Okay, there is none. But if I ask to see the second row of this thing, there is one, but it's called row 3. Right, and so it can be sort of confusing to you if you get yourself in trouble. I think the best thing probably to do is to create a new data frame and assign, fill in the values you want. But the indexing can get a little bit confusing. Other things don't have this behavior, so you have to be careful with it. Okay.
Is there a way to call the row that has row name?
It would probably be, so the columns I can put $sign. What row has name 3? Yeah, there is, but I don't know. What row has name 3?
You put like row dot names of.
Yeah, might work, right? I'm not going to try. So anyway, so you have to be sort of careful there with the objects in R. Arithmetic is easy, right? Like if you wanted to divide 2 vectors, well, you guys have corrupted my AA by now, but you could just do that division, and it will just do the component-wise division, right? Because if you look at AA and BB, right, 1 divided by 2 is 0.5, 10 divided by 6 is 1.66, right? So doing arithmetic is no problem at all, Oh, what is it, Jen?
Do the autofill of, because AA is like you have 5, either 5 or 6.
Let's see, what is it doing here? So
It's repeating B.
It's repeating B.
Oh,
that's funny. Yeah. So 10 divided by 6, 12 divided by 79, 5 divided by what?
By 2.
By 2.
NA by 6.
Yeah, NA. Yeah, very, very stupid behavior. Right. I mean, these should all be NA. Yeah.
What
Yep.
do you have divided by 0?
That's inf, right? Inf.
Oh.
That's a really big number. Yeah. Okay. Different from NA, right? Okay. There's a negative inf too. Yeah. That's a really small number. Okay. Let's see, what else do we have here? So division is okay. There's some, obvious summary statistics, right? Here I show you mean, median. There's no standard deviation, so I do the square root of the variance.
SD.
There is an SD? That's Excel. Just SD? Let's confirm this. I always do the square root of the variance. Now you're telling me there's a standard deviation. So you're saying this is the same as SD? SD. One less parenthesis. There you go. All right, same thing. Okay, and then you saw mean and median up there. And of course, any of these functions, you can always do question mark and get the help on it. And notice, the function of the function, no problem there, of course. Let's see, so there's summary statistics. Writing data, right? So I showed you how to read that in. How do you write data? Write.csv, that'll do the trick. I give it a couple arguments here. The first is the data set, and the second is the name of the file for the output file, right? So I'm going to save whatever's in my data set to this file called mydataset.csv, and it's going to go on my desktop because that's where I set my working directory. So if I look here on my desktop, it wrote out this file, and if you look at it, there it is, right? That's my data set that I created in R. Now it did create an extra column for the row names. If you want to get rid of a column in Excel, click once on the left to highlight it, click once on the right and say delete, and it's gone. Now in Excel, okay, this is a stupid thing about Excel, right? Is that if you want to have column names, they have to go in the first row. There's no way to change the A and the B to say attribute A and attribute B. So sometimes in Excel, we just sort of sacrifice the first row to be the column names, and that's sort of life. But you have to be careful because, it's sort of like you have to be 2-based, right? Not 1-based, not 0-based, but you're sort of like 2-based. So I think that's what I wanted to say here. Yeah?
By default, is it an and or when you rewrite?
The default behavior on write.csv, I think, is an overwrite, but let's see. Write.csv, it can append also. Append equals false, so default would be overwrite. Yeah. Okay, let's see here. So this is in Excel. How do we read that into Excel? Well, you could right-click and you could say open with. And then how do you delete a column? I just showed you that. Click on it and say delete. Arithmetic in Excel. So this is sort of cute, when you play with your spreadsheet here. If you want to add 10, add 10 to column A, right? Or I think I did column B in this one. I can type, as soon as you type equals in any cell in Excel, that's sort of like the magic sign for it to start doing something. And you see up here in the little formula box, the equals shows up. And I could say equals B2, right? That's how I call this one, column B, row 2, equals B2. And this one even has, blue highlighting and everything. And I hit return, and there it is 2, right? And so then this one would be equal B3. And there it is, right? Now, if you don't like that, you can do something even better, right? You can say equals, and you can click there, and it writes in B2 for you, and you say plus 10. And then if you don't write doing it every time, you can do a couple things. See how the corner here is little like notched out on the corner? If you drag on that guy, it'll sort of do the autofill for you, right? B3 plus 10, B4 plus 10. And this thing will give you some options if you don't want it to do that autofill, or if you just want it to copy or things like that. And of course then, since this is a function of this, if I change this one, that one will change along with it, right? So if you wanted sort of a static copy of it, you could get that by doing edit, copy on this thing, copy, and you could do what's called edit, paste special. So this paste special, whenever it's copying, pasting in ways that you don't want it to, you can do paste special. And here I would paste just the values and the number formats as opposed to the formulas. And so now this is a static copy. So I can do whatever I want to this one, but this one will stay static, right? OK. So let's see. That's sort of arithmetic in Excel. I showed you that. There are some functions in Excel to sort of do some basic stats, not too much. But if you go insert function, and then there's if you go to all, you just get an alphabetical listing of every function Excel has. If you want to browse and sort of see what it has, you can go to the statistical category. Of course, the statistical category is just a subset of all, as the name would imply. But you can do some basic calculations here. Let me just get rid of this stuff. So if I wanted to do like the mean, in Excel it's not called mean anymore, it's called average. Okay, so we just go here, average, average, and you say average, and then it brings up this sort of dialog box, and you say, it looks like it wants 2 numbers, but 1 is enough. And actually if you just sort of click on column A, it'll fill in for you, A colon A. It doesn't care that there's a word, attribute A there, it'll just ignore that. And it'll compute the mean as 7.666, just like R would. Insert function, all, I could do the median also, which will be the middle number, which would just be 10, right? And then just like in R, insert function STDEV, standard deviation, estimates the standard deviation based on the sample. And so you say, give me the standard deviation of column A. And just like we got an R, 5.859465. OK, so Excel has a lot of these really basic stat summary measure functions built in. And it's kind of nice if you have a spreadsheet, because then you can go back and change this data, and it will update these functions for you. OK, so let's see. Does that cover what I was going to say? Working with data in Excel, use insert function, all, statistical to find alphabetical listing of functions. We had the average. I showed you the median. I showed you the standard deviation. OK. Yeah, that takes care of all that. So I think that, that gives you sort of enough background to start playing with both of these. And, for most of the stuff we're going to be doing, initially, this will be enough. The real cool things to learn, of course, are the plotting, which we're going to cover in Chapter 3. But in terms of manipulating data in R and Excel, I think that'll sort of give you a good background to go on. Does anyone have any questions about anything I said so far today? OK, so the last thing to talk about in Chapter 2 and is the sampling, which they talked about on page 47. So why do we care about sampling? Well, when I tell you, say data mining is for large data sets, I mean, the first thing you say, is how large is large? Well, that sort of depends, right? And the point is that in some sense, it's sort of the fact that it's, not 10 observations starts to create some challenges for you. I mean, 10 observations I can look at, okay? 1,000 is already, starts to be large because I can't look at it. And as it gets larger and larger, there's fewer and fewer things you can do. So in that sense, it doesn't matter how large is large. We're not going to look at really large data sets in here because I'm going to be playing with R on my PC. But depending on what sort of data sets you have other ways of manipulating the data. But regardless, you always want to somehow have some way of sampling the data, right? Because some questions that can be answered on the whole data set can be answered a lot more efficiently by taking a sample. Now, in statistics, we often talk about sampling because we have some large population and we can't afford to get all the data from it, so we just take a sample, right? I want to know what fraction of all Americans are going to vote for a certain presidential candidate. Well, I can't afford to ask all Americans, but I can afford to ask a sample, and the sample, if it's representative and chosen correctly, might give me a close enough answer to what I'm after. So in data mining, we sort of play the same game, but the context in data mining is that we're doing the sampling not because we can't get all the data, but often because we have so much data that it's going to be slow, inefficient, and unnecessary to do the calculation on the whole data. So for example, if I have, what's that?
We have map reduce.
Well, yeah, right. I mean, you could compute, but if you get the same answer either way, right? I mean, it doesn't matter, right? So if I want to compute a mean for millions and millions of numbers, and I'm going to round it off to 1 decimal anyway, if I can take a random sample, I get the same answer, right? So that's sort of the motivation. Now, the mean is a good example. The mean from the sample, the mean of the whole data set, as long as you did the sample fairly and didn't set the seed to 301, then you have no problem. But something like the max, right? Not so good, right? The max of the sample, the max of the whole data set, those are going to be very dissimilar. So depending on what you're interested, sampling will sometimes give you sort of the answer in a more efficient manner. Also, sometimes the sampling isn't so obvious, like what objects you should sample, and I'll talk about that a little bit too. What I want to say is sort of this I copied down from the book, and I think it's funny because it's completely circular, right? So it says using a sample will work almost as well as the entire data sets, as using the entire data sets if the sample is representative. So what does it mean to be representative? A sample is representative if it has approximately the same property of interest as the original set of data, right? So it's very circular, but the point is it depends what you're after, right? Some things you're after, like I mentioned the mean or something like that, the sample will give you a good enough answer as long as you did it sort of in a fair manner. But other things, the sample may not preserve that property, something like the maximum. The sample maximum is going to be different from the population maximum, and so you're going to suffer there. So anyway, I wanted to talk about sort of some basic sampling. So the first thing sort of is the simple random sample, which is simply the names out of the hat, right? I'm just going to draw k names out of a hat of n things, right? So every item has the same probability of inclusion, and every sample fixed size has the same probability of selection, right? So this is sort of the standard names out of the hat paradigm. And in statistics, some people will say, SRS, right? It's just the simple random sample, the most basic thing you can get, right? Simple random sample. And this is generally the type of sampling that you're used to. Now, the question is, what are the things, right? If I imagine the data as being the matrix, then the things are the rows or the objects or the observations. And I just sample those randomly. But if your data doesn't really fit into that paradigm, then it's hard to know, like, what are the things, and I'll talk about that in a second. And then the only other thing to watch out for, is should you do it with replacement or without? And often that doesn't make a difference, but in some cases it does. And so it's important to think about that. And it's obvious what that means, right? With replacement, you sort of throw the name back in the hat so you can get it again, whereas without replacement, it's sort of a sample of unique items, right? You can't get the same person twice. And then, of course, the more complex schemes, the book talks a little bit about stratified sampling. There's also cluster sampling, Latin hypercube sampling. There's a lot of different sampling techniques that sort of preserve the fairness, but also sort of increase the uniformity, which decreases the variance. Okay, so there's an interesting experiment sometimes people do when they talk about this, which is like, I let you flip a coin 5 times and write down, head, head, tail, whatever you get. And then I let you pretend that you flip a coin 5 times, right? And it turns out that people sort of, when they pretend, they get a lot more uniform than when they actually do it, right? Because the sampling can actually give you some funny stuff, right? Because anything is possible. So sometimes you want a little more uniformity. So there's some other schemes that sort of ensure that, right? Like you can imagine a sort of a coin where you sort of ensure that you get sort of 50% heads and 50% tails, so that you don't sort of get this extra variability in there, right? Question?
Could you say a little bit more about the application of each case with
Oh, the difference between these? Okay, so I should give you an example of when one would make much more sense than the other, right? So, gosh, off the top of my head, let me see if I can mention a case where you could get yourself in trouble. So, I'm drawing a blank. So I'm drawing a blank on this one.
So, for example, if you're phoning people to ask a question, you'd better not phone the same person twice. It's going to be very annoying.
I like
so
that one.
that should be done without replacement.
Yeah, I can understand like the case without the replacement. I'm not sure like in what scenario you would want like a with replacement.
Well, there's that, and if you're going to run up against the boundary, right, it could be bad because then if you're sort of the sample becomes you keep sampling and keep sampling without replacement, like by like at some point you know who you're going to get. It's the guy that you haven't got before, right? So.
That makes sense.
Okay, yeah, I'm at a loss to sort of give you good practical examples of where one is more important than the other, but there are certainly cases where it matters to some degree, and maybe we can.
The coin flip is a good example, right? Heads can occur both ways.
Yeah, so coin flip would be with replacement, right? Because the second flip you don't say, I know it's going to be tails because we ran out of heads, right? So there's a case there, right? Yeah, anyway, you should just sort of pay attention to which makes more sense than the other. And if you develop a scheme, you should pay attention to which it's doing. In Excel, you know, it's rare that you really need to sample in Excel because you get sort of only 65,000 rows or 100,000 rows. But if you wanted to, there is a rand function in Excel that sort of acts as a random number generator. It's one of the worst random number generators that exists, you know, and you can play some games with it and sort of see, you know, different weird things it does. But if you call this rand function, it'll spit out a random number between 0 and 1. And then you could sort on this column and say, like, take the first n. And, you know, I'll sort of demonstrate that for you, right? So suppose here's the log file. So suppose I say I want to take a random sample of 100. So one easy thing I could do is just come over here and say insert function all rand, and say OK. And that gives me this rand. Whoa. Why is it negative? Oh, that column has stuff in it already. Okay. Let's clear out some room here. Okay. It's the first time I got a negative number between 0 and 1. Okay.
Well, you said it wasn't a very good random.
Yeah, no, it's not that bad, right? Okay, let's try that again. Insert function rand, rand, OK. There we go, 0.877. Okay, and now I just double click to fill it up. Now you see every time you sort of do something with it, it changes, which is funny, right? Anyway, these are random numbers between 0 and 1. If it bothers you that they're changing, here, I'll paste a static copy of them. Edit, paste special, values. Okay, there we go. Now they changed again, but at least now they're not going to change anymore. Okay, so those are random numbers between 0 and 1, and it filled up the whole column with them. And then I could do something like sort, you know, A through Z or Z through A, and it'll sort, right? Oh, hang on, that's not the right behavior. So okay, that's sort of interesting what it did. It assumed that the first one was the row name, or sorry, the column name. And there's no column names in here, so let me try and do that a little bit better. Data, sort, expand. Then I have to tell it no header row, right? Because it was thinking, yeah, Excel is pretty, okay. It was thinking that the first one was a header row. And I'm going to sort it by column K, right? Column K. Okay, there we go. So now the smallest one is first, second, okay, et cetera, et cetera, et cetera, et cetera. Okay, so if I take, say, then the first 100 of these, that would be a random sample of 100. Now, would that be with replacement or without replacement? That would be without, right? Because there's no way I could get the same row twice. If I wanted to with replacement, you could still sort of call rand and then let rand determine what row you take, and then you could take the same row more than once. But anyway, that would be a nice way to get a simple random sample without replacement in Excel. Okay, so here I showed you some screenshots, insert function rand, and then I sort by that thing, and that works. Okay, in R, there's a random number generator in R you can use too, but there's also a function called sample, which is pretty nice, which I have a few minutes I can demonstrate for you here. So here's the help on sample. It takes some arguments, takes the x, which is what you're trying to sample, the size, which is how many you want, replace, which defaults to false. So if you want with replacement, you have to write that as true. And you can actually even give it probabilities, which is nice. So let's see here. The next one I say here, explain how to use R to draw a simple random sample of 10 observations with replacement from the first quantitative attribute in the data set, stats202 log .text. So if you look at this data set here, the first quantitative attribute is this one here. Well, we could pretend it's quantitative, right? We know it's not, but it looks quantitative. So I could say, let's do a simple random sample of that one. It really should be categorical, right? We know that, but if you didn't, you could say it's quantitative. Okay, so I want to draw a simple random sample of that. Let's see. Do I still have? I don't have that data in here, do I? Let's see. Stats202 log.txt. I don't think that I do. So let me read it in. So actually, so here's the. Sorry. So hang on. Maybe I have it in there. Data. Yeah, I think it's in there, right? Yeah, it's still there. OK, so I have it in there. So I want to draw a simple random sample with that. So I'm going to claim that the following will work. To do that, I'm going to say, so I did it in 2 steps. You could have done it in 1 step here. So let me sort of say what each thing is doing here. So first of all, the function sample, right? I give it some arguments. The first thing I tell it is what I want to sample. So I say sample sequence 1, 1922. So 1, 1922 in the sequence thing is exactly the integers from 1 to 1922 inclusive, right? OK. And so that's what.
1 colon.
Oh, that would be the same thing, right? 1 colon 1922, right? The sequence thing is nice because it actually lets you go by 2s or 4s and things like that. It takes some other arguments. So that's the same thing. So I put that there. What else do I have here? 10, right? That's how many I want. And then replace equals true. So when I do this thing, basically I get a sample of 10 integers between 1 and 1922, right? Every time, right? OK. And if you want to set the seed, there's a set.seed argument. But by default, I think it's setting something off of the clock. So that'll give you a sample of 10 integers. So how do you use that to draw a sample of 10 rows from the data set? Well, you simply go here and you say my sample, and I say, OK, let me tell you this one. So if I say data 7th column, that gives me that. I could also say data $V7, because if you look at the data, it named the 7th column V7, right? If you look at that. So those 2 things are equivalent. So if I say data V7 and I say, give me the rows that are in SAM, right? What's SAM? SAM is the name I gave to that previous thing, right? So let me just sort of show it up here. So SAM is what I called my sequence of 10 integers that I sampled randomly from 1 to 1922 with replacement. And then I say my sample would be data, the 7th column, and I want SAM, right? So the 7th column is just 1-dimensional, so I just have to specify these rows. So that will work to give me a sample of 10 observations from that data set. So let me just sort of show you that. So take my 10 observations, and then that's my sample, right? Those are the 10 numbers I'm going to take. Those are the 10 rows I'm going to take. And then I say my sample store as 7th column, those guys. So if you look at my sample, there it is, right? There's your sample. Now, what's interesting then, of course, is to say, OK, so the mean of my sample, right? So I'm pretending this thing is numeric, even though I know it's not really numeric. I just wanted to use this data set. So the mean in my sample is 281.6. However, the mean of all of data $column 8, right, is, oops, 7. There we go. 299.3933. So 281 is not the same as 299.3933. So of course the answer is like, well, you should have taken a bigger sample. The question is, how big of a sample you should take. And so one thing I think that I'll talk about, let me sort of get back to the slides here. So that's how we take a sample of 10. The next thing says, if you do the sampling repeatedly, how far is the mean of the sample from the mean of the whole column on average, right? So if you do that repeatedly, and I think we'll do this next time, we can see how far the sample mean differs from the true mean. And you'll see, I think it averages, I'll sort of put up a loop next time to do that, but it averages, you're off by about like 20 or 30 on average. And then the next thing we'll do next time, so I'll show you that, and then we'll increase the sample size from 10 to 100, see how that changes. And what you're going to see, and we'll do this next time, is that it scales by the square root of the sample size. So if you haven't seen that before, this is sort of a good demonstration of that. And there's a sort of simple math you can work out to show you why that happens. Basically, the variance scales linearly, but then the standard deviation, which is really on the same scale the original data, is going to scale like the square root of the sample size, right? So if you increase the sample size by a factor of 10, you sort of decrease your error by a factor of the square root of 10. So I'll demonstrate that to you last time. But since we're just about out today, I think I'll leave it at that. Are there any questions before we take off for the 4th of July? Nope, no questions? Okay, so yeah, next time we'll finish up chapter 2, and then we'll get into chapter 3 where we make some plots. Textbook is not around. Oh, wait, what am I supposed to say? I'm supposed to tell you that they're taking orders through engEDU library. So if that means anything to you, if not, I'll try and send around an email explaining that. But it sounds like we can order them, and that sounds like we don't have to pay, right? So I'll send around an email about that.